So far, so good.
Cool. I'm recording now as well, so you're good to go whenever you're ready.
Cool. Hi everyone. My name's Ben. I'm a senior developer advocate for AWS, focusing specifically on serverless technologies. Just quickly, if there's any questions that I don't manage to answer at the end of this session, you can ask me directly on Twitter. It's Benjamin_L_S. So this talk is going to be a kind of whistle-stop tour of serverless technologies for web developers. We're going to cover quite a lot of services. So yeah, I'm expecting that you might have some questions after. So I'll do my best to answer that. Okay, so as I said, I'm a developer advocate for AWS, and that's a kind of interesting role in itself, in that I'm an advocate for the developer that uses our services. So I go to a lot of events, I speak to a lot of developers such as yourselves, and I take all your feedback and all of your kind of concerns and the way you're using our technologies, and I feed that back to the product team inside of AWS, because I'm associated to the product and the engineering team. So that's one half of the role, and the other is that I write a lot of example code and a lot of applications and blog posts and release posts about how to use some of our serverless technology stack. So that's why I wanted to speak to you today. I'm really interested in speaking to some more local meetups around the UK, and it's even easier to do that at the moment because of the kind of virtual situation that we have. I've been a web developer for 15 years prior to joining AWS. I'm from Brighton, and I'm an avid skier, and there's a reason why I'm telling you that, which will become apparent later on in this presentation. So why am I here today? I first started building with serverless technologies. My first project was something to do with Slack. It was a chatbot about 3 years ago, which is quite a good way to get into using serverless. And I quickly realized that building with serverless technologies will soon be a thing that people will ask, why wouldn't I start with serverless rather than why should I? And that's because of a number of reasons, but essentially serverless technologies makes it easier to build web applications and to be able to do that faster than ever before. And you can do all of this without managing a single server, without dealing with any container orchestration, without ever having to restart Apache again. And you get able to go from prototype to production really quickly because of the way that serverless technologies scale. And I'll go into that in some detail in just a moment. But really the goal of this talk is to show you how to use some of these services to be able to build applications that offer more customer value, that have reliability, resistance, and scalability, and to be able to do this as quickly as possible. So I hope that that's what you take away from this, on how to use some of these services to sort of help you develop with these 5 kind of key goals in mind. So what I want to do is to walk you through a typical web application stack from a really high level, from the front end to the back end to a database. A very simple abstraction of a web application. I'm going to map on some serverless services to each one of these components, and then we'll redraw this application or this stack and start to see how the way you build with serverless will change a little bit as you use some serverless technologies. So first we'll start with the front end. And at AWS, we have 2 really good tools or services to host static content on the front end. We have AWS Amplify Console, and we have Amazon S3. So Amazon S3 is cloud storage for the internet. It's an object-based storage system that's super durable, and it's virtually limitless in terms of what it can hold. Individual objects can be up to 5 terabytes in size. And this is great for things like logs, backup files, customer records. Pretty much anything that you need to store in the cloud can go into Amazon S3, and it can be durable and safe. Then we have a service called Amazon CloudFront, which is a content delivery network that you can put in front of your Amazon S3 bucket. And you can use this to route HTTP requests to various buckets and to various content within that bucket to enable you to deliver dynamic content directly to the browser. So this is one way of hosting a kind of static front-end website. Another option we have is AWS Amplify Console. And this is a really cool, fairly new service for hosting web applications. So this is already built on top of S3 for you. It's integrated with Git, so it has built-in continuous delivery and continuous integration workflows. So what that means is you can point it to your GitHub repository, and then every time you make a commit to a certain branch that you're tracking, that will automatically get deployed out to production or to whichever environment you've configured it to deploy to. It's already integrated with CloudFront. So when you roll your own solution with CloudFront and S3, with Amplify Console, that's all handled for you. You just point it to your GitHub repository, essentially, and all of that's taken care of for you. It's got built-in support for authentication, for custom domains. It's got support for rewrites and redirects, and it comes already integrated with some really popular frameworks like Vue and React, as well as static site generators, as it says here, like Jekyll and Hugo. So this is a really cool, really interesting service for hosting and deployment of front-end applications on top of S3. So we'll put that into our front end of our application stack and move on to the back end. So I've mentioned the word already serverless a few times here without really talking about what I mean when I say serverless, or what AWS kind of is referring to when they talk about serverless technologies. And typically within AWS, for something to be considered serverless, it should fulfill all four of these key tenets, right? So there should be no infrastructure to provision or manage. That means no servers to spin up, nothing to operate, nothing to patch. And it should scale automatically by unit of consumption. And I say unit of consumption because that's a distinction to unit of server or unit of container. It should have some sort of pay for value billing model. Another way of putting that is that you shouldn't have to pay for idle. So when the service is not being used, you're not getting charged for it. And it should have availability and fault tolerance built in. So because that's baked into the service, you don't need to configure an architect for that. So really, when we say serverless, we're not saying it's the removal of servers. There's still servers in serverless, but it's the removal of the undifferentiated heavy lifting that is the server operations. So that's a really important distinction because it means customers can focus on building the application that differentiates them from their competitors rather than focus on the infrastructure that that application sits on top of. So that brings me on to Lambda, which is our kind of flagship serverless service. And Lambda is a function as a service, which I'll get into in a moment. But before I talk about what Lambda is, there's a few things which I think always get missed out about what Lambda can do. These don't get talked about as much. So built into Lambda, you have automatic load balancing, auto scaling. It has failures and retries built into the service. Security isolation and OS management. This is all part of the Lambda service that is a whole other kind of subject that you could have a whole different presentation on. So just bear that in mind when we dive more into a Lambda function. So Lambda itself doesn't just sit in a vacuum. Typically it forms, it's formed of 2 or 3 different components, right? So you have the Lambda function itself, which provides a curated runtime experience or runtime environment for a bunch of different languages that you can use. Some of them are listed here. And you can use something called the runtime API to configure Lambda to run in pretty much any language you'd like to code in. So if you want to run a Lambda with PowerShell or PHP or Scala, you can use one of the open source runtime API layers to build your Lambda function in any language that you're comfortable programming in. It's completely agnostic for your language. So that's the execution environment that runs a bit of code in the cloud. Then you have the event source, which is the thing that triggers your Lambda function to run. And this can be a number of different things. It can be a change in state from a database that your Lambda function is pointed to or listening to. It can be a request from an HTTP endpoint via an API gateway. It can be a change in resource state from some other service. But basically the event source is the thing that triggers or invokes your Lambda function to start executing that code that you've placed into it. Then the third component is the event destination, and that's the output that your Lambda function sends its results to. So that could be anything that depends on the business logic of the application that you're trying to run. Now, there's a few different execution models that you can use with Lambda, and understanding this is really core to understanding how to use serverless technologies and the difference between these three. So the first is synchronous push-based model. So in this case with Amazon API Gateway, it calls, it's called from an API resource. Here it's the order resource. And this will invoke a Lambda function, which may then interact with another service, and then synchronously sends back the response to the client. In a synchronous model like this, the client waits for the response back from the Lambda function before it will proceed on to the next event. So that's a synchronous invocation of Lambda. Then you have something called asynchronous invocation, and this is more of an event-based model with services like S3 or SNS, where they will invoke the Lambda function. Lambda will then send them a response to say that it has received the invocation to start running, and then that service that invoked the Lambda function can continue with the next thing that it had, knowing that Lambda will handle that asynchronously and the response will be handled separately. So that's an asynchronous invocation. And then you have stream or poll-based execution model. And in this case, with examples like Amazon Kinesis or DynamoDB, the services are going to send out a stream of changes, and the Lambda service will actually poll and pull down those changes for the records and invoke the Lambda function on your behalf. So they're the three sort of typical execution models that you will see with Lambda, and we'll go into some of them in a bit more detail in the next slides. So another really important thing about any serverless service is the pricing model, which is something that really sets it apart. So in terms of pricing for Lambda, it's billed in 100 millisecond increments. So it's very fine grained versus a server or a container billing model. So you pay only for what you used up to the nearest 100 milliseconds. And you're charged based on the number of requests and how long your function takes to execute to the closest 100 millisecond. So that's the one factor of the billing model. And the second is the memory that you have configured to allow your Lambda function to run on. So you could allocate up from 120 megabytes up to 3 gig, I think it is, of memory available to your Lambda function. And this is a really key part of how you think about application performance with Lambda, because what comes with adjusting the memory available to the function as you go up from 128 to 256 and on, is that it linearly scales the amount of CPU available to your function. So if you have a function that's executing some very computational heavy code and you allocate more memory to it, it's very likely that it will execute much quicker, and therefore you'll be paying less for that execution, which is kind of contrary to how most things in computer science work, where it runs quicker and you pay less. It's kind of an unusual billing model to get your head around. The other thing I wanted to draw your attention to is that the free tier in Lambda goes a long way. You get up to 1 million requests and 400 gigabytes of compute every month. So in terms of discovering how to use Lambda, you can go a long way just on paying pennies really to really understand how you can benefit and how you can use the technology. So we're going to use Lambda for the backend compute functionality of our serverless web application stack. But as I mentioned, we need a way to invoke a Lambda function to run. So we say that APIs are the front door to your backend services. And we have a service at AWS called Amazon API Gateway. So Amazon API Gateway didn't define the API space. API gateways have existed for a long time. But what makes API Gateway really unique is that it fits inside this box of what is serverless. And it has a number of capabilities that are only possible inside of a kind of managed cloud environment. So for example, it's able to do things like DDoS protection that's built into the service with throttling and usage tiers. And this can be done at very large scale, but it won't cost you anything when you're not using it and when you're not sending requests to your Amazon API Gateway endpoint. So it can be configured to have edge points fronted by a CDN. It can have region points that only exist in an AWS region, and it can have private endpoints for things like internal microservices. And behind that API can be pretty much HTTP facing service on the internet. So in terms of a web application, API Gateway can handle your inbound application requests and route those requests to your Lambda function to perform compute and then return that back to the client that sent that API request. So this is how our stack's starting to look, with AWS Amplify hosting the front-end static content that will send requests to Amazon API Gateway, which will then send requests to our Lambda function, perform some compute. Typically, you're probably going to need a database of some sort. So databases at AWS is a massive topic. If you look broadly across the industry, there's something like 340 different database options, not at AWS, across the whole of the industry today, but they broadly fit into one of these 7 categories: relational, key value, etc. And each of these models is built for a specific purpose, and each with their own use case. The strategy at AWS is to make sure that there is the best purpose-built database in each of these categories, so you shouldn't have to compromise on which you choose. It's important to know as well that you can overburden your database if you pick the wrong model for the purpose that you need. So one example of this is back in 2004, Amazon Retail was using a relational database, and in December, which is the busiest month of the year, they hit an outage because they weren't able to scale up the database any further. So a bunch of engineers made a correction of error document to look at what they could do differently. And they found that they were using this relational database as a key value store, which is a great example of how to overburden a database beyond its intention. So as a result of that, a few other engineers went off and wrote a paper called the Dynamo paper, which led to what we now know today as DynamoDB, which is a completely different database model. So I'm not going to go through each one of those website models, but typically most web applications can be served by one of these 2 types, either a relational or a key value database model. And I'm going to talk just about the key value database, because this one is the one that's truly serverless. So in this model, it's kind of self-explanatory in the name, in that you store a set of values against a single key. And the design point for the key value store is that it can horizontally partition keys with almost limitless scale. So because we're using a key to look at one item, we can do that consistently and performant at scale. So if you can make the assumption about your data that you'll always be able to access it with a key, then you can provide single-digit milliseconds for that lookup. And we have a service at AWS called Amazon DynamoDB, and this has had a lot of great innovations over the last couple of years. It's multi-region, it's multi-master, it has an on-demand pricing plan, so you don't have to provision any individual resources, and you only pay for the individual requests to your data. So it's truly serverless in that sense. And it serves some of the biggest workloads on the internet today. So here's our complete kind of serverless web application stack. But there's a better way to draw it when you start to look at how you can add other serverless services to it. So if we have our client, our browser running in our client running in the browser with some code executing in browser memory, such as Vue.js in this example, that will make requests to our Amazon API Gateway by Ajax, for example. Amazon API Gateway will then route those requests downstream to a corresponding Lambda function. Lambda will execute the code to process that request, and it might write or read from a database and return some information back to the client. All of these services scale automatically to meet the demand. You have Amplify Console to host and deploy the front end of the serverless application. And then you might want a IDaaS, Identity as a Service provider like Amazon Cognito or maybe Auth0 to be able to authenticate calls to your Amazon API Gateway resource so it's secure. And typically in a more realistic production environment, you're going to have multiple Lambda functions, and each one of these Lambda functions will be triggered or invoked by a different API request. So you might have a post method to get a signed URL, you might have a get method to get an activity, And each of these functions will have a very small scope to do a very discrete piece of compute. Then you might still use S3 to store other files like GPX or XML or video files. And here you have a kind of, we're getting closer towards now a realistic web application. But we can go way further. So after showing people that, a common question I get sometimes is, should every service or every Lambda function talk to another using an API? And the answer is, well, probably not. So there's a helpful kind of conceptual way to think about that your microservice, which comprise your application. If you think of it as an iceberg with the piece above the water being your public facing endpoint, this is the bit that your website is making requests to. And then everything else, the bulk of your application, is below the waterline. And the public doesn't need any knowledge of these other microservices, but you still need to pass messages and communication between those services. So there's better ways to do that than using an internal API, which is what I'm going to talk about now. So we have a service called SNS, or Simple Notification Service. And this is one of the oldest services that exist at AWS. It's used very heavily by customers of all sizes. It lets you publish messages into what's called a topic, and then that topic has the ability to push or deliver those messages out to the services that have been subscribed to it. So this is an asynchronous process, which means once SNS has received the message, the thing or the publisher that sent that message to SNS can carry on with its next task, knowing that SNS will deliver that wherever it needs to go. The consumer can then be anything from an HTTP or HTTPS endpoint to a mobile device or a queue, or in this case, a Lambda function. So as messages are put onto the topic, the service can then go directly and invoke your Lambda function, and these messages can then be consumed and executed. There's another service which is called SQS, or Simple Queue Service. And this is integrated really deeply within AWS and with Amazon itself, actually. The product side makes this sound really complicated. It says that it's a simple, flexible, managed messaging queue service to send, store, receive messages between software components at any volume without losing messages or requiring other services to be available. Essentially, it's a managed queue service. And it's really simple. It's literally in the name. And what this does is it sends messages downstream, or services downstream can pull this queue and take messages off the queue and act on them. So it's another great event source for Lambda. Now we have another way of thinking about how we send messages between services, which is to think of them as events. And this is events in the more specific sense of how a system might react to changes. So the important thing with events is that they can be observed and not directed or not command driven. What I mean by that is that in a command model, each command is explicitly issued to the recipient. So the example here, to create an invoice, is an explicit call which is acted upon. Events, on the other hand, are merely observable by other systems. So a process will create an event to say that a customer has ordered a widget, and the other consumers can do different things based on how interested they are in that event. So this example here, you have one service that's just making a note or making a log of that event, another is taking an action, and two other services are completely disinterested because it's not something they're concerned with. So thinking of your internal application in this way allows you to keep your services nicely decoupled from each other. We have a service called Amazon Event Bridge, which is ideal for this kind of interaction. And this is a serverless event bus that allows you to easily ingest and route events from lots of different places. These can be from other AWS services, can be from your own application, or it can be from a third-party SaaS integration partner. So just like SQS and SNS, there's no infrastructure to manage your provision, and scaling is completely handled for you, and you only pay for what you use. And I think Event Bridge will become, and it's already starting to become, a way that we see people building applications more and more, where they consume events from an event bus and then they put events back onto the event bus, and the event bus filter decides which events will receive, or which services will receive each event. So all the logic is built into the event bus filter. So going back to our architecture, we'll add a messaging layer, and that will be Amazon Event Bridge. And that will take in events from every time a item is saved to our S3 bucket. And then we need one more layer for orchestration. So we've been talking about how to connect lots of different microservices together, but there's also times when you need more kind of coordination than just a set and forget asynchronous messaging. And as we know, Lambdas are stateless, they're ephemeral, and they're event-driven. They exist in the cloud, but there aren't many apps with only one function or one entry point or one model, one component. So typically there'll be multiple Lambda functions. And it's common to have lots of these functions needing to talk to each other in different ways. And probably you'll need some kind of database as part of this. And you'll need some kind of queue. More often than not, this is what we see. And typically you'll need to talk to something outside of your cloud as well. So at this point, this is more like what a serverless application will look like. And the question is, how do you orchestrate the passing of state between all of these different services when the Lambda function itself is stateless? And for that, there's a service called AWS Step Functions, which lets you coordinate multiple services into workflows so you can build and update apps really quickly. So these are defined in JSON. You can visualize them in the console or in your IDE as well now with the new recent Viz Studio integration plugin. And then you can monitor these executions in the console, and you can step through them and build out sophisticated scalable workflows to handle the passing of state across your serverless services. So this is the final layer that we'll add to our application, which we will create a workflow based on a bunch of different Lambda functions to perform some additional compute, which we'll walk through in a minute. So here's our final fairly comprehensive serverless application here. And you might have guessed this is a real application. And going back to the first talk earlier on, I spent my first couple of weeks on lockdown building this because it's something I wanted to spend time looking at lots of pictures of mountains. So this is a kind of think like Strava for skiing, where you're able to record data on your mobile device about your day in the mountains, skiing or snowboarding, and then go onto this application to upload that data, and it will plot it onto a map and give you some statistics about your day. So what I want to do now is play a 2-minute video which walks through how those services map onto this application. And the reason it's a video is that I've had to slow it down a lot because otherwise it would happen in a matter of seconds. So you'll see how the architecture that we've just built maps onto a real interaction with that website. So hopefully this will play.
So on the left-hand side of the screen here is my Freshtracks application website. And on the right-hand side is the architecture that we're building. And as I move through the application, I'm going to highlight on the architecture some of the services that are being used. This is the homepage of Freshtracks, and you can see there's some info about some of the SaaS integrations with Auth0 and Zendesk. First of all, I'm going to log in, and I'm going to log in with the Auth0 integration. This is using my Amazon username and password. This takes me back to the homepage of Freshtracks. So you can see that I'm in because I have my profile picture here. I'm authenticated. What I'm going to do now is to upload a new activity which is being recorded and exported from my phone. And then this web application will plot that activity onto a map and record some summary data about that activity to a serverless database. I'll click on the activities link, which will take me to the up page. And now I'm going to browse to my activity file and just drop that in here. So at this point, I'm just going to slow our demo right down and explain what's happening. The client makes a request via Amazon API Gateway to a Lambda function to get a pre-signed URL for our S3 bucket. It then uses this pre-signed URL with the JavaScript SDK to upload the file directly to the bucket. Just takes a second because I've slowed the demo down to 25% speed. Now the file has successfully been uploaded, it will trigger an event which is captured by Amazon Event Bridge. This event is then filtered by a rule downstream to a service, which in this case is an AWS Step Functions Express workflow. The first task in this express workflow is a Lambda function which processes some GPX data on that file. It then sends that to the next function, which saves some of that metadata to an Amazon DynamoDB table. The third and final function in the workflow publishes a message to an AWS IoT core topic. This sends a notification to the front-end client signaling that the workflow has completed and the display list component can be updated with the newly added activity. If you look now at the front-end client, you'll see that this is about to happen, and there you can see our new activity. Now, when I click on this new activity, a request is sent again to Amazon API Gateway to get the activity from the Amazon DynamoDB table, which returns the GPX data back to the front-end client, which is then rendered onto the map, as you can see here. And if you look just below the map, you'll see some of the statistics that was created by our step functions workflow, such as the total distance and the total elevation speed. This was saved to our Amazon DynamoDB table.
Okay, so that's a really quick run through of how that architecture kind of interacts with each other. You can expand beyond your own systems, since as your applications need to include kind of third-party SaaS application functionality, which is beyond your immediate control because you don't own that code. How can you get information from those systems into your own application? And for that, we have all of these SaaS integrations with Amazon EventBridge. So all of these companies you see here enable you to stream events directly into your event bus, which you can then consume and use in your application. A couple of examples we've seen are people using Zendesk tickets to run sentiment analysis to determine if they're negative or positive and escalate accordingly. People using Datadog events to auto remediate and restart servers and stuff like this. People using Auth0 user events to visualize with dashboards on Amazon QuickSight. The possibilities are really huge. So how do you get started? I suggest to start with a framework. I can't stress that enough. There's a number of different frameworks out there. Some are third party, and there's some great third party frameworks. There's some that are open source and also built by AWS. I recommend to use SAM, which is the Serverless Application Model by AWS. And this is an abstraction on top of CloudFormation, which is our infrastructure as code language. So you can use YAML or JSON to build out entire applications and make pull requests and build your infrastructure this way. So here's an example with these 20 lines of code. This builds a Lambda function with an IAM role and an API gateway resource and a DynamoDB table. So those 20 lines are building all of these things that you see here, and they can all just be saved in a GitHub repository, and pull requests can be made on them. And that's how your teams can build serverless applications as infrastructure. So to sum up, by combining all of these different serverless services, it is possible to build very scalable web applications from prototype to production very quickly without managing a single server, and with a payment model that's completely aligned to the consumption and the requests driven on the application. If you need more resources, that website is actually public. It's myfreshtracks.com, and that has a link to the GitHub repository, which has all the codes. You could even deploy that application locally and look at how that's put together. So that's myfreshtracks.com, and of course you can reach out to me on Twitter if you have any more questions. And if you do have time to answer 2 questions on this, just to say how useful this talk was for you, that really helps us to improve for the next time we deliver a similar talk. So thanks very much for listening, and I'll hand back over to you, James, unless you're able to take yourself, are you?
Okay.